3. Natural causes of climate change. Astronomical. The natural alteration of glacial and interglacial periods is partly explained by the natural astronomical cycles of the Earth and the solar system. Obliquity of the Earth's axis. This obliquity is not fixed. When the inclination is minimal, cooler summers reduce melting and favour the formation of ice caps. This variation has a 41,000-year cycle. Elliptic orbit and precession. The Earth's orbit around the Sun is in fact a flattened circle, and the Sun is not at the centre. Therefore the distance between the Earth and the Sun changes during the year. Moreover, the Earth's rotating axis turns on itself. This means that at the time when the North Pole points towards the Sun, our summer, the Earth will not always be at the same distance from the Sun. When the distance from the Earth to the Sun is greatest during the summer, the ice caps are most resistant to melting. This rotation of the axis has a 23,000-year cycle. Eccentricity of the Earth's orbit. The ellipse of the Earth's orbit exhibits a certain elasticity, again influencing the distance between the Earth and the Sun. This variation in the ellipse follows a 100,000-year cycle. Greenhouse effect and gases. Without a greenhouse effect, the average temperature on Earth would be minus 18 degrees Celsius instead of the current 15 degrees Celsius, and life would be impossible here. The atmosphere of the Earth, like a garden greenhouse, lets in energy from the Sun and traps it. Part of this energy is re-emitted as heat by the land and outwards to space. The Sun mostly sends us energy in the form of visible light. 30% of the Sun's radiation is directly reflected by the upper atmosphere, the clouds and the Earth's surface, in particular by ice and snow. The remaining 70% is absorbed by the Earth's surface, soil, oceans, and by the different components of the atmosphere. This absorption of radiation warms the Earth's surface and the atmosphere. Energy is then re-emitted towards space in the form of heat or infrared radiation. It is the so-called greenhouse gases that prevent a portion of these infrared rays from escaping directly into space, absorbing them and then re-emitting them back towards Earth. Most of the greenhouse gases, water vapour, carbon dioxide, methane and nitrous oxide, already existed in the atmosphere before the appearance of man. A series of human activities, however, have provoked not only a significant increase in the emission of certain of these gases, but also the emission of new greenhouse gases. Human factor. Warming up from last Ice Age average of 9 degrees Celsius took the Earth about 22,000 years. It is projected that in the next 100 years our average temperature will rise the same amount, 6 degrees Celsius. In addition to the worrying speed, it will also be the highest average the Earth has seen in 100,000 years. Consequences. Rise of sea level, ocean acidification, relocation of the foliage, more frequent and stronger extreme weather.